Hello everyone! Today we start a new topic on profit maximization. And this is our study plan. This is what we need to cover this week. So first of all, we'll start with definitions of total average and marginal revenue. We've covered the cost. Now we'll need to add revenue. And we'll also learn relevant formulas for this. We'll try to draw the total revenue curve. We'll cover alternative firms' objectives, what the firm can try to achieve, and how this will affect their decisions in terms of output, how much output they will want to produce, depending on what they want to get. We'll learn the difference between normal and supernormal or abnormal or economic profit. And we eventually will end up with profit maximization condition. A very simple formula, a very simple rule, which will tell you how many units of output you need to produce in order to maximize your profit. We'll see that it's a very simple formula. If you follow this rule, you can be guaranteed to earn the highest possible profit. We'll also learn the idea of break-even, and we'll learn how to identify the break-even point on a graph, how to find it, and how to interpret this point. And at the end of this lesson, we'll study alternative market structures. Well, I'll introduce you to different types of markets which can exist and their effect on profit in the long run. This is our study plan for this week, and we will start with the idea of total average and marginal revenue. Total revenue is simply the revenue received by a firm from selling its goods or services, from selling its products. Total revenue is simply a product of price times quantity. It can be calculated if we multiply number of units which we are selling, quantity of output, times the price of each unit. For example, we sell 5 items at £10 each. It means that our total revenue is going to be 50. Average revenue. Average revenue is revenue received from selling 1 unit of output. It's revenue per unit, and it's actually equal to the price. So it's very simple. Average, like any average value in economics, can be calculated by dividing total by quantity. For example, average cost was total cost divided by quantity of output. Similarly, average revenue is total revenue divided by quantity. Have a look. Total revenue is price times quantity, total revenue. We need to divide this by quantity. Quantity and quantity will cancel out, and we will be left with price. That's why average revenue is simply the price of a product. Next, marginal revenue. Marginal revenue is the additional revenue which you get from selling an additional unit of output. It shows you how your total revenue will increase when you increase output by 1 extra unit. So how much more revenue will you be able to generate if you will sell 1 extra unit of output? So the formula is written down here. What is important is that marginal revenue is not equal to price. Not at all. In fact, it can even be negative, as we will see later, which means that extra sales can actually reduce total revenue. Let me show you an example to illustrate this idea. Let's imagine that we sell different number of products. For example, price of our product is equal to 10, and at this price we sell, let's say, 5 units of output. This implies that our total revenue will be 5 items times £10, 5 times 10, which will be equal to 50. Let's imagine that we want to sell more. We sell 6 units of output, and in order to sell this extra unit, we reduce the price. The price goes down to £9. This is the law of demand. To sell more, we need to reduce the price. What will be our total revenue? Now we sell 6 units at £9 each, which means that our total revenue is actually lower. It's £48, not 50. Let's have a look at this slide, which will illustrate this further. Generally, what you need to know is that total revenue, which is received by firm, can vary depending on characteristics of demand. And in fact, increasing production, increasing output can lead to a lower revenue. This depends on what is called elasticity of demand. Demand can have different shapes and forms. Demand curve can be flat or it can be steep. The flat demand curve is called rather elastic, while steep demand curve, in fact, is inelastic. The concept of elasticity is, in fact, rather important in economics. Elasticity of demand reflects the responsiveness or sensitivity of demand to changes in price. Let me give you an example. Let's imagine that we operate in 2 different markets. Let's say we produce cars and we sell our cars in the UK and in Europe, where characteristics of demand are different. In the UK, the demand curve is flat, elastic, while in Europe, the demand curve is rather steep, inelastic. What does this mean? Let's imagine that we initially allocated at point A. We sell certain number of cars, Q0, in both markets at the same price P0, let's say £20,000 per each car. Then we decided to drop the price by the same amount. Price goes down from P0 to P1 in both markets, and of course it will take us to a new point on the same demand curve to point B, again in both markets. We've dropped the price by the same amount in both markets, however, the quantity reacted very differently. You can see that in the UK, where demand is elastic or very sensitive, quantity nearly double. The increase in quantity is proportionately larger than the drop in price. This change, this increase from Q0 to Q1 is very large. It's bigger than the change in the price itself. While in Europe and another market with inelastic demand, change in quantity is insignificant. In fact, it's lower in proportionate terms compared to drop in price. We've dropped the price by a significant amount, however, we didn't really get many customers. This demand is not sensitive to changes in price, inelastic. So that's the general idea. However, the concept of elasticity is beyond your syllabus, so we will not go any deeper into this concept. However, what you need to know is that elasticity of demand, of the features, characteristics, steepness of the demand curve can result in totally different reaction of total revenue to changes in price and quantity. And this graph will help us to understand how increasing quantity can in fact lead to lower revenue. Let's have a look. Same situation, same two markets with different demands. We start operating at point A, and what is important is that total revenue, which we generate originally, is shown by this blue rectangle, by this shaded area in both markets. Let's call it total revenue 0. Why is it this shaded rectangle? This is because total revenue is equal to price times quantity. The area of any rectangle can be calculated as height times its base. Our height is price, our base is quantity. That is why this shaded area under a point on the demand curve represents in fact total revenue. This is how much we earned originally, shown by the blue rectangle. Now let's drop the price in both markets. As we know, it will take us to point B. In other words, quantity will increase in both markets. We will now sell more. What this also means is that total revenue will change. Our new total revenue at point B will now be shown by this purple rectangle, this shaded area. And you will see that it will be very different in markets with different elasticities. In the first market, in the British market, a reduction in price has led to a larger total revenue. You can see that this purple rectangle is actually bigger than the blue rectangle which we used to earn in the past. So new total revenue is greater than the original total revenue. While in Europe, in a different market with steep demand, with inelastic demand, situation is different. We've dropped the price by the same amount, quantity increased by a little bit, and our new total revenue, this purple rectangle, is now smaller compared to what we used to have. In other words, total revenue 1 is now lower than total revenue 0. So that is why sometimes reducing the price is not necessarily beneficial for you. Even if it leads to increase in quantity, increase in number of customers, this does not necessarily mean that your total revenue will increase. It depends on features of the demand. And this slide also illustrates how marginal revenue can in fact be negative. This is because increasing output leads to lower total revenue, which means that additional revenue which we generate from selling these extra units is actually negative. How can we calculate marginal revenue? Marginal revenue shows the difference between total revenue figures. It shows the change in total revenue divided by change in quantity. So how can we calculate this? When quantity increases from 5 to 6, total revenue decreases from 50 to 48. So change in total revenue is equal to 48 minus 50, new value minus old value, minus 2. Divided by change in quantity. Change in quantity is new quantity, 6, minus old quantity, 5. In other words, when output increases by 1 unit, revenue drops by £2. So marginal revenue in this particular example is -2, while the price is actually positive. So price is equal to £9, while marginal revenue is equal to -2. They are not equal to each other. And in majority of situations, price will be greater than marginal revenue in majority of scenarios. So please remember that marginal revenue, an additional revenue which you earn from selling your products, is not equal to price. It will be lower than price. Next thing which I want to show you is an example of a question which can be asked at the exam based on this material we've just covered. So have a look. A wine merchant will supply bottles of champagne at £10 per bottle, but is willing to offer a 10% discount on the total bill if 50 bottles or more are purchased. What would be the firm's marginal revenue for the 50th bottle? As before, please stop the video, write down your answer, and continue when you are ready. Ready? Let's have a look how we can tackle this question. So what information is available to us? Original price is £10, but we are prepared to offer a 10% discount. Let's write this down. Price used to be £10, but the new price can be the original price minus 10%, i.e. £9. This is what we are prepared to offer, but this depends on the number of units purchased. We are supplying champagne at £10 for any amount up to 50 units. If 50 or more bottles are purchased, then the new price will come into play. So let's have a look. This price P, will be correct for quantity equal to 49 units. However, if 50 or more units are purchased, then the new price will be offered. So these are the data which are available to us. And now we'll need to calculate the marginal revenue for the 50th bottle. So how total revenue for the company will change if it's increasing its sales from 49 to 50 units. So how exactly we will be able to change our total revenue when we jump in our production from 49 to 50. So let's calculate our marginal revenue. Marginal revenue shows change in total revenue due to change in quantity. What is change in revenue? This is our new revenue minus original or old previous revenue. What is change in quantity? It's our new quantity minus old quantity. New quantity is 50 units. Previous original quantity was 49 units. In other words, change in quantity is going to be 1 unit. Now we need to calculate change in total revenue. What is total revenue? Total revenue is price times quantity. We can sell 49 bottles at £10, i.e. get a revenue of 490. Or we can sell 50 bottles at £9. New quantity 50, new price is £9, which will generate a revenue of £450. Now let's plug in this data into our formula. We'll need to compare them. So strictly speaking, as our output increases from 49 to 50, our total revenue will decline from 490 to 450. Our new total revenue is 450. Our old total revenue is 490, which is minus £40. Our marginal revenue is minus £40. Total revenue drops by £40 when output increases from 49 units to 50 units. In other words, this deal is not profitable to the company. We are losing £40 in revenue, so this wouldn't be profitable. So let's have a look at the options available. 450, 9, 1, minus 40. So the correct answer here would be D, minus 40. Let's have a look at this illustration, at this table. Here we are given some numbers for our demand curve. We have some quantity and some prices which we will be able to charge if we want to sell this number of units. We can sell more if we reduce the price to 7, to 6, to 5, and so on. So we need to calculate total revenue, and this can easily be done by multiplying quantity by price. 1 unit at £8 each, total revenue is equal to 8. 2 units at £7 each, £14 in total. When we sell 3 units at £6 each, it will be £18 in total, and so on. So this is our total revenue shown by this purple column, purple figures. And now we need to calculate marginal revenue, which is shown in green. How can we do this? Marginal revenue shows how total revenue changes when we change output by 1 unit. Output will increase by 1 unit all the time. We'll need to have a look how total revenue changes. When we increase output from 1 to 2 units, total revenue will jump from 8 to 14 pounds. That's the difference, and it's equal to 6 pounds. When output increases from 1 to 2, total revenue goes up from 8 to 14, i.e. it increases by 6 pounds. Additional revenue generated from selling this extra unit is 6 pounds. When we increase production from 2 to 3, total revenue will go up from 14 to 18. In other words, marginal additional revenue will be equal to 4. Next, when output goes up from 3 to 4, total revenue will increase from 18 to 20, i.e. by 2 pounds, and so on. And please pay attention, what is interesting here. Initially, we've had some positive revenue. We've sold more units and total revenue increased. 8, 14, 18, 20, it increased. But now it reached its maximum. When we increase output from 4 to 5, we sell more units. However, our total revenue doesn't change. There is no change, and our additional revenue is equal to 0. Marginal revenue is 0. No change. And if we continue increasing our output from 5 to 6 and further, we can notice that total revenue will start to decline. Initially, it declined from 20 to 18, which is -2, marginal revenue is -2. And then marginal revenue increases to -4. So in fact, we are generating negative revenue. Our total revenue goes down the more we produce. So here, initially, total revenue increases for this range of units. Then it remains unchanged. Total revenue reaches its maximum. And then total revenue starts to decline. Marginal revenue is positive initially, then it becomes equal to 0, then it becomes negative. Let's try to see how it will look like on a graph. So first of all, we've drawn our demand curve. Here it's labeled as AR because it's strictly speaking, it shows the price. Our demand curve is the price line. It shows how price will change as we change output. As we change output from 1 to 7 units, price will drop from 8 to 2. And strictly speaking, this curve will represent the demand relationship. So here, price or average revenue represents the demand line. This is what we've drawn. These are our prices from our table. And now we can also add the marginal revenue line according to the figures which we've calculated. So have a look. Initially, it's positive. It drops from 6 pounds to 0. It crosses horizontal axis somewhere between 4 and 5 units. Marginal revenue will be equal to 0, and then it goes into negative territory. This is how exactly you draw these curves, demand and marginal revenue line. We might need to do this in some of the exercises in seminar when we'll start looking at profit maximization in different market structures. We will need to draw this. What is important to remember is that both demand and marginal revenue line will start from the same point. They originate from the same point, somewhere on the vertical axis. Then they are both downward sloping, but marginal revenue line is twice as steep and it crosses horizontal axis. So when you try to sketch a graph, it should look like that. Demand curve, some downward sloping demand. Demand cannot be negative. It should stop somewhere above a horizontal axis. So this is price, this is quantity. Price and demand, price line or average revenue line, demand and marginal revenue line will originate from the same point, but marginal revenue line will be steeper than demand. It will be twice as steep to be precise, and it will cross horizontal axis. So when you sketch a graph, you need to draw it in this particular way, as shown here in this particular example. If we plot total revenue line, it will look like this. It will have this concave shape. In other words, it will have a point of maximum. This is what you will need to remember. Total revenue originates from 0. If we don't sell any units, our total revenue is apparently equal to 0. We don't earn anything. Then the more we sell, the more we earn, but this is only true up to a certain amount. In this case, up to the area, up to the production level, somewhere between points 4 and 5. Between output level equal to 4 or 5, we'll reach maximum. Our total revenue is maximized. So somewhere here, our revenue is equal to 20. This is the maximum which we can generate. Maximum, somewhere here, maximum total revenue. And this will be achieved somewhere between 4 and 5 units. So the more we produce up to this production level, the more we will earn. However, beyond this point, total revenue will start to decline. In other words, we don't need to try and sell maximum number of units, because doing so can actually reduce our total revenue. Because the firm wants to earn maximum amount of money, it doesn't need to push for highest possible quantity level. Sometimes it's not necessary to work to the best of its abilities to maximize its capacity. Sometimes it's better to reduce production level in order to maximize your revenue. In this case, it will be achieved somewhere between 4 and 5 units of output.